I don't know why I skipped over you. Hello. All right. Thank you everyone for coming. This is the weekly web development workshops. It'll be kind of a supplement to the learning-based projects that you're all on, kind of learning the tools of the trade. Just a quick overview of what we're going to go over in this web development workshop. This first one is going to be over Git and GitHub, and not that. The one next week will be over TypeScript and kind of basic JavaScript. This is what we use to code. The week after that, we'll be going over React, which is what we use as a front-end library. So it's what actually makes things visual, everything displayed on the web page. The week after that, we'll go over Mongoose and MongoDB, which is our database provider that we use. So now that you have an application, how do you actually store data with it and have it be a dynamic application rather than just a static web page? After that, we'll go over like a client, API, and server relationship. So if you have all these pieces, how do they all interact with each other? If you click something on the web page, what happens on the server that's actually running the website? Then we'll go over Next.js, which is how we deal with routing. So if you click this link, it takes you to this other page. How does that connection work and how do you set those up? As well as some stuff about APIs, which we'll talk about later. Then the week after that, we will go over like error handling in a web application. So if someone gives you some bad input, how do you handle that? Both on like a function that you're running on your server, or if someone like inputs an invalid form value, so what's a good way to deal with that? The week after that, we'll do something. We'll kind of figure out what we best need to supplement with, but this covers just about everything. And then the last week will be kind of a summary, tying everything that we covered all together, and then getting a little bit of feedback from you guys to see how we can improve the course in the future. Say course, the workshops, because these are open to the public. So that's the plan for this. We hope that by the end of this, combined with your individual learning-based projects, at the end of the semester, you'll have enough knowledge to hop onto a nonprofit development team and have a really smooth transition into there. My name's Andrew. I'm one of the co-directors. Normally, Xavier would be here, but he's out of town. Normally, Alex will also be here. He's taking a bit of a break, though. So today it's just me, but I'm happy to have all of you. Let's see if I got this. We got Sully, Michael, and Peyton, and Logan, and Nia, and Eric, and help me out. Autumn. Oh, okay. You're not on my list, which is okay. Okay, fantastic. Good to have you, though. Good to have you. I love to see it. So today we're going over Git and GitHub, which is at a high level, how we kind of manage our software and the different versions of it and how we collaborate on code. If you ever have any questions, feel free to stop me. This is a small group, so it's not that you're not interrupting too much. But let me just get right into it. And I'll talk about the motivation of why we learn all this and all of that. So let's say I want to write a program where I give it an array and it will give me back the largest value in that array. I'm just using Python because it's easy for me to pick up, but it would work in any language. So let's do maybe make a new function, call it max value. It will take in an array. Syntax isn't too important here. I'm just kind of writing a function to demonstrate how we use Git. So let's give a default max value of 0. And then for every value in the array, let's check the value of that array element. And if it's greater than our maximum value, then that is our new max value. And then at the end of that, we just want to return whatever our max value is. So we can test this if I just print out like the max value of some array of numbers. So 1, 84, 6, and 15. If I run this program, let's see. We can see it takes in all of these and just tells me the maximum value of that array, which is 84. So I saved that. I'm done with my program. Now let's say whoever's asking me to write this program adds some new requirements. Hey, instead of returning the max value of this array, give me the sum of the entire array. So take every single element and add them all together. So, okay, I can do that. Maybe let's call that array sum. So let me change that down here as well. And then instead of max value, it'll be total value maybe. And then instead of checking the maximum value, we'll just do total value plus equals array at that position. And then we will return, we will return the total value. And then I'll save that. Let's test out that program, make sure that works. It adds them all together. That's perfect. So I'm done with that. I'm going to exit out of that. And I come back maybe a day or two later. I'm going to open it right back up. Yeah. So I have my program. I know it works. And now my boss comes back to me and says, hey, actually, that was wrong. Can you change that back to that function you had before where it returns the max value? And I said, oh, I did that yesterday. I wish I could go back and save my work. I closed out of the program, so I can't hit Control Z. I can't revert to the way it was before. So that's kind of frustrating. So when you're working on a project, you're usually kind of saving things as you go, and it's kind of discarded after you finish, besides an undo button. But it would be really cool if you had a save tool that could keep a log of every change that you made, along with what those changes represent. So here I wrote a program to find the max value, and then I hit save. And then later on, I changed the program to add up all the values in an array, and then I hit save. But then when I tried to change the program to like what it was before, when I saved the first time, I wasn't able to. It would be very convenient if I could just click a button and kind of change the program to the exact way it was one save ago, two saves ago, 15 saves ago, a good history of all the changes I've made. Does that analogy? And then another motivation for Git, and we'll get into how this all ties together. When you're working on teams, you might have a bunch of people saving to the same project or like even the same file. So if you're in a group working on a class paper, not so much today anymore, but maybe like 10 years ago, you might have like kind of all been responsible for the different sections of a paper, and you had to email it back and forth or pass it around on a physical USB. You only had that one document that you were all kind of working out of before the days of Google Drive. So then at the end, when everyone's done with their parts, you have to bring together multiple versions of the same document that's kind of been passed around and deal with everybody typing in a different font, everybody putting together their own kinds of section headers, and spend a lot of time getting that ready to turn in. So the same problems exist when you're coding on a team. I might be working on the visual part of a coding project, and you might be working on the functional part of a coding project. And then we need a good way to bring those parts together. So this is where Git comes in as a tool. At a high level, Git is a local tool that runs on your machine that keeps track of your changes. You can save your changes as you go, and then put your changes on the cloud so that other people can see them when they want to. Since this keeps track of the changes, it's easy to revert back to previous saves in the event that someone breaks something, or you just need to go back to the way a program was before, like I did with my maximum value code here. So similar to how Control S saves a file, I make a change, it's unsaved, I hit Control S, it saves it. The Git has a aspect of it called a commit, and that's Git's version of saving. It saves everything you commit while also describing what has changed. Let's see. So let's try what I did before again. I'm gonna open up this over here. So let's see if I can use Git to kind of improve my workflow. I should have saved what I did before. I'm going to write that maximum value function again. Make sure that works. Yes, it works. So let's try what I did before again. First, what I'm going to do is I'm going to go to the source control tab in VS Code and hit initialize repository. A repository is just all of the code in your current project. So if I have a code repository for a class, that repository just contains all of the code for your class, kind of similar to like a Google Drive folder for a class project. So I've made some changes. I can see there's this green symbol here. And now I want to save these changes and keep a permanent record of them so I can revert to it later if I need to. What I can do is I can go over to the source control tab, hit this plus arrow, and type in a message, maybe max value function. I wrote a max value function. I can commit or save those changes. Later on, I'm just going to comment this out in case I need to go back. No, that's what Git's for. I'll change this back to array sum. The requirements have changed. Now I need to change what this function does. Make sure that works. That works. So now I've made some changes and I can see those changes pop up here as well. And there's some kind of blue line saying what changed. I deleted this line. I changed this line from max value to array sum. And I can see what those changes are. If I'm on the same source control tab and I click this, I can see this is before when I saved, and then this is the changes I've made since. So now I'm going to do the same thing. I'm going to commit those changes, essentially saving them. So I changed the max value function to an array sum function instead. Can you all read that, by the way? I'm going to commit those changes or essentially save them. And now this is when my boss comes back to me and says, oh, hey, that max value function that you wrote yesterday, can we actually use that? So, oh, crap, I already saved. This is what I have right now. But now that I'm using Git, I have a history of every time I save or commit, and I can go back to previous commits. Down here, there's this little commits tab. Put this up a little bit more. And I can see there's those two saves I made before. There's the max value function, and then this is when I changed it. Click on this commit, and I can see, oh, before, this is when I had the max value function. That was the first thing I saved or committed. Up here, when I changed that function to my array sum function, that's the changes that I saved. This is what it was before I saved. This is what it was after I saved. So if I want to go back to this, I can just right-click this and hit, let's see, restore. And now my program has the max value function again. And I can maybe once more, again, commit and say, change code back to max value function. And commit again, and I can see this is kind of my save history. So we can kind of see how I can go back to previous changes whenever I want. I can see a long history of it, and these persist forever. So if I exit out, close out my computer, restart, there's still this permanent log of changes that I've made. Okay, I'm screen share. Good. Any questions about what a commit is? Yes. It would not. It would Control S would save it like as normal on your computer, and you can keep making changes until you've kind of finished a block of work. So like I wrote this whole function or changed this whole function, but you might save in between two commits. But then this is just kind of a checkpoint where I did this function. I did this function, and I can kind of hop between them. Yes. You were to do it on You're ahead of the curve. Yeah, I'm not going to be teaching the command line arguments today, just because it's learning Git plus the command line arguments, but they will be available in a resource. And the add is what staging is. Now I'll get into the staging in just a second. Good question. Anything? All right. So that works great for one file. I can see its revision history and go back to previous saves. But what if I'm working on the same or on multiple files at the same time? That gets a bit more complicated. I might only want to save or commit my changes to file A, but not to file B. So this brings up another Git concept called staging, which is where we choose or stage which file changes to save or commit. So let's say I have another program. I think this one will be my copy it. No, I didn't. This one will be my array sum function. Copy this phrase. And then maybe I'll just change what this value is to show that I have two sets of changes. So I'm working on two programs at once, and then maybe I start writing program 3 .py. Start writing a third program. I'm not really going to define what this does too much. That's not how you comments in Python. And I'm not sure what it'll do now, but it's just kind of a work in progress. If I go back to my source control tab, I can see there's 3 sets of changes I've made to each of the different programs. Program 3 is still a work in progress. I don't really have it doing anything yet, so I don't necessarily want to commit that and make a permanent record of that checkpoint. I haven't really hit any milestones or done anything. So what I'll do is when I hover over this plus button, it says stage changes. That's kind of preparing them to be committed. So I'll prepare my changes for program 1. That's fine. I just updated a value there. And I'll also stage my changes for program 2. If I click on this, I wrote that array sum function again. And I want to commit both of these, but not the changes to the third program. So these two are staged, and then I can write another message here saying what that commit is. So I'll say maybe finish program 2, changed a value in program 1. I did both of those things. I'll commit to both of those changes. I can see still here program 3's changes are listed as new changes that I haven't committed yet. But in my commit history, I can see that a single commit held changes for 2 different programs. And in the future, if I commit and do a bunch of other stuff and I want to revert to this, I can revert to the exact state that this was at this commit with program 1 and 2. So staging lets you track multiple file changes at once and commit multiple file changes at once. Any changes about or questions about staging? All right. So that's the basics of Git and what it does. It just lets you keep track of your changes, who made them and when. And then now we get to move on to GitHub. Pull this up. Y'all can pull out your laptops as well. We'll need them in just a minute. YouTube, I'll post a link and everything. I'll make sure you get it. Okay. All right. So we've covered Git. Now it's time to cover GitHub. GitHub is kind of a centralized location for code collaboration. Developers can upload and download to and from this remote repository, which is again just like a folder for all of our code. It's similar to Google Drive. You can download, change, and re-upload files, but Google kind of holds the main copy of the file. Same thing with GitHub. We can all make changes to it, but GitHub will hold the true code, essentially. I'm going to send out a link in the Discord. If everybody could go to it, that would be awesome. So this is kind of a place where we can store some code that we're collaborating on. If you click on commits here on this repository, similar to how I could do this on my local machine, I can actually see that there have been 4 commits on this repository. This first one was just to create the repository. I can see exactly when this was done, who did it, and what the change was. So it looks like Xavier created this repository last semester. And now there are 3 that I made earlier today. So let's take a look at them. Let's see. On this one right here, I can see I created 2 new files, 2 additions, and I deleted a previous file that was there. So I added example file 1 and example file 2. And then I made another commit where I created example file 3. I can see exactly what I did there. And then one final commit where I added the word example to example file 1. So I changed this text here and just added the word example. So I can see a history of all the changes I've made to these files, exactly when and exactly who, which can be good for accountability. So let's say that now we want to actually contribute to this kind of repository and start using some of this code and collaborate on kind of a team project. Can everybody click this code button right here and then copy this URL, the HTTPS one. And then inside of, if you go open VS Code, let's see, and then just go to some new folder. Some empty folder that you don't really care about. And then open up a command line and let me know when you're there. Folder. All right. So with that URL that you copied in the terminal, type in git, G-I-T, clone, and then paste in that URL and hit enter. So what this does is this takes that repository that's in GitHub and makes a copy of it on your computer so you can see all the files and tinker with them locally on your computer rather than GitHub, which is in the cloud. It's basically like downloading a file from Google Drive. And then after you've done that, go into that folder. So if you're in the command line, CD into that folder. Or if you're on VS Code, you can hit File, Open Folder, and then click that new folder and hit Select. Yes. In a moment, we'll all try to create a file and then also edit one of these 3 example files and then upload the changes to the GitHub repository in the cloud. But if we all make changes at the same time and try to upload them to GitHub all at the same time, things could get really messy, especially if we were all trying to change the same file. You can imagine if everyone is trying to edit the exact same Word document and then bring all those together at the same time, you're going to have some conflicts there. So to separate out changes and so that we aren't stepping on each other's toes, we introduce Git's concept of branches. Let's see. All right. Whiteboard time. That you're not going to be able to spin. That's fine. All right. So similar to branches on a tree, our code can have branches as well. So if we think about what's currently in GitHub, this is kind of our main branch. It's our kind of master version of the code, the one source of truth. Now let's say I want to make a change to some of this code. Instead of changing this directly, which we all might be trying to do at the same time, if we really run into some problems, instead I'll branch off onto here and make my changes separately from the main code. I can do this. Nia can make her own branch. Peyton can make his own branch. And we can all code separately without stepping on each other's toes because we're all on different branches. I can keep making changes over here. I can keep making changes over here. Nia can make them over here, so on and so forth. And then later on, when I'm kind of done with those changes, I can then bring them back into the main code and incorporate them there. Nia can do the same later on. Peyton can do the same later on. So essentially, when I branch, I take the existing code, I can make some changes to it, and I can bring it back and incorporate my changes into the main code. Is there anything I can clarify about branches? Let's see what else we got. So that just lets us not step on each other's code while we're not stepping on each other's toes while writing code. So let's all try making a branch of our own now. We can see down here, this is the branch name I'm currently on. It's called main. I'm on the main branch. If I hit this source control tab, there's this branches tab down here. So could everybody hit this plus button where it says create branch? And then type in a branch name, maybe just your GitHub or your NetID, whatever. Just make a new branch name and then hit create and switch to branch. You're going to type in Git. Everybody get this extension called Git Lens. Sorry, I thought everybody had that. So you're all able to see the branches now? Yeah. There's the main branch and there's my branch. If I make changes here, it's completely separate from the main branch. Yep. Try to avoid spaces in it. It can get complicated. But... So now that we're on a separate branch, any changes we make won't affect the main version or the main branch of this code. So now that we're all on our own branches, let's make our own commit. So if everyone could just make a new text file, call it whatever you want, and just add some text to it. You should be able to see your new file in the source control tab. And then let's commit those changes, yeah?
Switch to your branch.
Did you hit the new branch button with the source control?
Yeah, I made a branch.
Oh, you didn't hit create and switch. What you can do is you can just click on that and then you can click to switch. I made a change here. Now, if everyone could commit their change. So first I'm going to stage, say I want to commit or save these changes and add a nice message. Made text. I'm going to hit commit. So I have committed to those changes. I've saved my new file that I've made. If we could all do that, that would be awesome. Anybody still working on committing? Okay, so we've all committed, essentially saved our changes, given them a nice name so we can look back on them in the future. But now, how do we actually push those up to the cloud in GitHub? For that, we have to push our changes. Now, this will upload all of our current commits and we'll store them in GitHub. So let's give that a try. On the same source control tab, you should all see this button that says Publish Branch. Does everybody see that button? And this just tells GitHub, hey, I have a new branch for this repository that I want to tell you about. So I'll hit publish branch. And I should be able to see that branch in GitHub. We'll take a look in just a sec. All right. Running out of time, so I'm going to go ahead and move on. If I go back to the code on here and I hit this branches tab, I can see all of your branches that you made. Let's see. And so let's look at Sully's branch. I'm picking at you because you're on the top. It says you're one commit ahead of main. That means you made one group of changes that isn't on the main branch. So let's take a look at what that is. 5 commits. I can see there's the ones that I made, and then he branched and added on to it. So he created a text file. Let's click on that commit. I can see he made an empty file called sully.txt. I can go back onto the branches, and I can see who's this? This one right here. And I can see first commits with some text and some more text. So you all have your separate branches that are separate from the main branch. But how do you actually go about bringing those changes from a branch into the main branch of the code? So for that, we make a pull request, which is basically saying, hey, I have these changes. Can I incorporate these changes into the main branch of the code? Just kind of asking permission. And then someone can review that pull request, or it's called a PR, and approve or deny it. And if it's approved, Git will automatically merge the 2 branches into one. So let's give that a go and demonstrate. So let's see. I guess Sully, since I saw your thing, do you see this button where it says compare and pull request? If you could click that and just hit create pull request. And let me know if you've done that. All right, so now I can see here on this pull requests tab, I can see there's a pull request from Sully, which is him just asking, hey, can I bring these changes into the main branch of the code? I'll review them and I'll say, great job, and I'll approve his changes. So now at the bottom, you should see a button that says merge pull request. Can you go ahead and hit that for me? And now it says merge. So what just happened right there? Okay, the main branch. Sully made his own branch over here. He made a commit. And then he pushed the commit to GitHub. And then he made a pull request saying, hey, can I bring this commit that I made and move it into the main branch of the code? And I said, yes. And then he merged it. So now if we go back to the main code for this repository, I can see now his file is there in the main branch. If I go to a different branch, like Peyton's branch, sully.txt is not there, but Peyton's test file is. All right.
Sully's file should be available in name.
Yes. So let's see. I'm out of time, so I'm not going to cover what happens if 2 people edit the same file. And then it's like, if you try to squash them together, whose changes to use? I ran out of time, so I'm not going to cover that. That'll be in some documentation somewhere, I assure you. But let's say now that you need Sully's changes to keep working on the code that you have. Let's see. If you all could, do you all see this branches here where it says main? And hover over and you should see a button that says pull. Do you ever see that? If you hit pull there, this will pull 2 commits into branch main. So what that does is you have GitHub's version of the main branch in the cloud and your version of the main branch on your local computer. When you pull, you literally basically download what's new from GitHub. So now exactly what's on my computer and exactly what's in GitHub for the main branch are the same. And then if I'm working and I need those new changes that are now in that main branch, I can right click my branch, or no, right click the main branch rather, and say merge branch into current branch. And just hit merge. So now I'm still on my branch, but I have my test file and Sully's text file. So just a quick recap, and then we'll be done. Git lets us have version control. We can look back at a history of all of our saves and revert back to them if we need to. It also gives us a method of collaboration. Multiple people can make multiple different changes, and we can pick and choose the changes that go into our main branch of code through pull requests, basically asking to incorporate a set of changes or commits into the main version of the code. Let's see. Next week, we will cover TypeScript and learn how to actually do that coding. It'll be, yes, on your individual project teams. Mine is going to start up next Tuesday. I'll send out an announcement for that if you're on the member portal. The others should start shortly after that. And those, they should supplement what we learn in here pretty well. We use Git and GitHub to keep track of all of our changes. So any code you write will be stored in GitHub, and that's how you'll retrieve it to work on it. Are there any questions I can answer right now? Yes.
Because obviously I wasn't aware of the software that have required. If there was somewhere I could look, I can just note it. Is that real?
Yes. If you're like, is there some document I can read or some resource I can use? It's in Notion.
There's so many like different things.
Yeah, sorry, it's
okay.
kind of a lot.
That's
But the first stop is to go into the Notion. Ignore the national resources if you can see that. But just where you start is members home and then the onboarding for the developers. Read this whole thing. It's long. I'm sorry. It'll get shorter in the future and better in the future. Yeah, read this whole thing. I'll tell you everything you need to download to get started. You'll definitely need Node next week. Yeah. I'll stick up here. I'll stick around up here for a few minutes if anyone else has questions. Otherwise, thank you all so much for coming. Great to have you. Share. Yes. The recording, we have a YouTube channel. This will be uploaded so you can review it if you need. And